Generation of three-phase power or the voltage is also be important for the examination point of view. The electrical machine which will converts the mechanical energy to electrical energy, but whose output is alternating current, then which it is called as the synchronous generator or alternator or AC generator also. Okay, but which it is containing two parts majorly. One is stator, then rotor. Okay, with respect to this synchronous generator and alternator, in detail we will study. Okay, in fourth module. There we can discuss. But thing is that how we are going to generate the three-phase voltage. That we need to understand the concept. Okay, then whatever the conversion which is to be taking place, that is based on what? The dynamically induced EMF principle. Okay, what I told in previous explanation. Okay, if it is a three-phase supply system, okay, which is having three windings. Okay, but I used for my explanation was R, Y, B. Okay, but in my notes, I used with respect to A, okay, and B and C. Okay, these will be differ from author to author. Okay, A, B, C also be a phases. Okay, how many terminals are present with respect to the one phase? Whether it may be a R phase or the A phase. For one phase, how many terminals are to be there? How many terminals? For only R phase. Two terminals. Okay, thank you. That is A and A dash. And B, B dash. C, C dash. Okay, but what I used? Starting terminal, finishing terminal. Okay, during my explanation, because the same method I am following in my lab. So that I followed that method. Okay, then with respect to the A phase, then B phase, then E phase. All are having a displacement of how much? 120-degree displacement. Okay, this is what? R phase. R. This is what? R phase. Okay, but it is taken as a. Okay, 0 to pi. It means 180-degree. Okay, this is what? 180-degree. Then this is 360-degree. Okay, this is what? One complete cycle. Okay, then what I did? I did 3 divisions. Okay, then this is R phase, then Y phase. Okay, Y phase is started from 60-degree displacement. 60-degree displacement. Okay, this is what happens. Here is 60. Okay, then with respect to the complete cycle, here is 60. What is the displacement which it is caused? 120. Y is causing 120-degree displacement. Then with respect to the B phase, this is also be 120-degree displacement. Okay, this is with respect to the what? One complete cycle. Okay, how it is causing that I will show the video. I will explain there. Okay, this is what? The generation of the AC voltage from fixed winding. Okay, the relative motion between the conductor and the magnetic flux will causes the induced EMF. That is alternating in nature. Then which it is called as a alternator, which is having a displacement of 120-degree. Because of all the three phases are to be get displaced by 120-degree itself. Okay, how we can generate this one? Okay, I muted that. Okay, but I will use my explanation using this video. I don't want caption. Okay, is my screen is visible now? Confirm me. Audio is clear?
Yes, sir.
Fine. Okay, here in case of three-phase generator, three windings are there. Okay, one is R phase, Y phase, and the B phase. Okay, with respect to that three phases, the windings are placed, windings are fixed, but the field is rotating. The relative motion between the magnetic flux and the conductor will causes the induced EMF. Okay, that induced EMF will causes the current to carry. Okay, you can see here, this magnet is rotating, flux will be cut by this conductor, will causes induced EMF. 1 minute. Okay, here, flux cut by the conductor will causes the EMF. Okay, this is with respect to the R phase. Next, which is get considered with respect to the Y phase. Okay, axis is what? The neutral axis. Then magnetic lines of forces. Okay, because of that lines of forces, which is causes the induced EMF itself. Okay, because the whatever the flux linked with respect to the conductor itself will causes the induced EMF. Okay, whenever the maximum flux is linked with respect to the conductor will causes the maximum voltage. Okay, then obviously which will lead to what? The controllability among the EMF. Then whatever the neutral axis which it is there to be get reversed in each direction, whenever which it is to be get rotating by the particular angle. Okay, then you will get the sinusoidal waveform corresponding to that, whatever the flux linking with respect to that conductor is changes. Okay, that current flow is causing because of that rotation of the magnetic field. Okay, here the whatever conductor which it is get linked with respect to that magnetic flux, then according to that, the whatever the EMF which it is to be get increasing will be increases, decreases. You can see here, due to this rotation, the magnitude of EMF is get changing its direction as well as its magnitude. Can you able to understand? Whatever flux linked with respect to that conductor is proportional to that of magnitude of the voltage. If the flux is less, then obviously the whatever the magnitude is, they also be there less. This is with respect to the R phase. Increasing and decreasing is happening because of flux. This is the sinusoidal waveform for cycle. One cycle is one complete positive half cycle and negative half cycle. 50 Hz means 50 cycles per second. 60 Hz means 60 cycles per second. What is frequency? Number of cycles per second, which is to be measured in terms of hertz. Okay, this is the generated voltage frequency. Okay, reciprocal of time period is also be called as frequency. Now I got R phase. Okay, one phase I got. Okay, then we can proceed for the another phase that will also be appeared. You can wait. Okay, N pole, S pole, the neutral. Okay, whatever the EMF which is to be get increasing will be get changing with respect to that time. Okay, because the whatever the rotation of that magnet with respect to that of conductor will causes the induced EMF which it is alternating in nature. Anybody confirm me? My audio is clear na?
Yes, sir.
Okay. Okay, brightness is changing here. Lamp is bright, dim, off. Then Y phase. What is the displacement angle here? 120 degree. Okay, the displacement which is to be caused by the Y phase is of 120-degree displacement. One minute, which it is shown here. Okay, means the conductors are to be placed at 120-degree itself. Okay, according to that displacement only, which will cause the induced EMF. Okay, you can able to see here the whatever the displacement with respect to that particular winding to that of Y phase is of 120-degree displacement for the phase 1, phase 2. Understood now? This is phase 2. It is Y phase. Okay, with respect to R, Y, magnet is moving. Then EMF generation is changing its magnitude as well as direction. The combination of both you can check here. All three phases. Okay, this is R phase, this is Y phase, this is B phase. The combination of all three together, what is to be happening with respect to that operation is also be going to taking place here. Resultant RYB. Understood how the three-phase power generation is taking place? Got my point? Anyone reply?
Yes, sir. Yes, sir.
Here, where we can use it for three-phase motor. Okay, then lathe machine, pump set. Okay, in all these applications, we are going to use the three-phase power supply. Okay, for the transmission of electrical power. Okay, this is the generating station. Then voltage to be get increased by the transmission lines. The power can be carried. There we are going to use what? Three-phase supply system. Getting my point now? What I am telling you. Okay, this is the application where we are going to use the three-phase power supply. Okay, but the small scale industry we are going to use it. Okay, you can see here, we got neutral black and B phase. What we are connecting? We are connecting the single phase power supply to for domestic application. For industries, what we are connecting? We are connecting the three-phase supply. Okay, where there will be a large power or bulk power is required, that can be get connected with respect to the three-phase, three-wire system. Okay, three-phase, four-wire system will be used where there will be a requirement of three-phase as well as single phase. Is my audio is clear? Confirm anyone?
Yes, sir.
Thank you. Okay, this is with respect to the application where we are going to use it. Okay, this is the three-phase power connection. Okay, with four-wire system. Okay, here what happening? I told the three-phase four-wire system. From that, three-wire RYB is connected to three-phase load. Okay, then B phase and neutral is what? B phase and neutral is the single phase. Then Y phase and neutral is the single phase. Then R phase and neutral is the what? One more phase. Okay, this is what? The three-phase, four-wire AC supply system. Understood this now? This is a self-explanatory. Remember this. Okay, same thing I will explain during your fifth model also. Okay, this is regarding to the understanding of how we can generate a three-phase voltage.